Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our Exploratory Data Analysis Bootcamp with Python, Seaborn, and Pandas. In this lecture, we're going to do an overview and a preview of the project that you will build in this course. In this course, you're going to learn how you can analyze features and find relationships of a data set. So we're going to start by loading in a data set, and then we're going to analyze the features and find relationships between the features. As well, we're going to perform data analysis and also data visualization. So we're going to learn how we can build different visualizations and graphs using our data to get insights as to what the data contains and what we could possibly do with it. For example, we're going to learn how to analyze the target feature, as well as how to analyze numerical features like the sale price of a house, overall quality, the year the house was built, the lot area, the overall condition, the first floor square footage, second floor square footage, and the number of bedrooms above ground. So we're going to learn how we can build histograms, bar charts, box and whisker plots, and more. For example, as you can see here on the screen, some examples of what we're going to do. We're going to learn how we can analyze numerical features. That means features that are on a range, as well as categorical features, such as MS zoning, which has 5 types. We're going to learn how we can quickly visualize all of our features at once and see patterns in our data. All right, so you can see some examples. We're also going to find relationships between features, starting with finding relationships between numerical features like sale price versus lot area. And this will help us see what features have an effect on the target that we're trying to achieve. Typically, with housing, you're trying to use features of a house to predict its price. So here are some more examples of everything that you're going to learn how to create. You're going to learn how to create these matrices of graphs. And we're going to do this all quickly and easily with Python, Seaborn, and Pandas. You're also going to learn how you can create a heat map here to get a color visual of the correlation between features. We'll also build box and whisker plots, as you can see here, to see more insights as to the average values and the distribution of values. And finally, we'll learn how to build conditional plots, so where we can have even more nuanced graphs. You can see here, we're comparing sale price versus overall quality, but we actually have 3 graphs because we have split our graph into sale condition types. So the first graph shows only where the sale condition is normal. The second graph shows only where the sale condition is abnormal. And the third graph shows only where the sale condition is partial. All right, and that way we're going to learn how we can perform very nuanced data analysis. Now for this course, you don't need any prior experience in data analysis or Python. We will provide you, however, a section on Python programming because in order to complete the bootcamp, you do need to know how to code in Python. So we will include for you a prerequisite section. If you already have experience with Python, then you can skip that prerequisite section and just jump straight into the data analysis bootcamp. And as well, we're going to be coding on Google Colab, which is a free online code editor, which means that you won't have to download or install any software to take this course. It's absolutely beginner friendly, and I'm very excited to take you through this data analysis bootcamp. Data analysis is a huge field, as is data science, data visualization. They're closely related to machine learning. Data analysis is often a crucial part of the machine learning workflow. So a very in-demand topic and hireable as well. So join me coming up in our next section where we're going to begin. Hello everyone, and welcome back to our course. In this lecture, we're going to start our project of exploratory data analysis. So here I am in Google Colab at colab.research.google.com, and I will get started. Our first step is going to be to load in our data set. So I've actually saved the URL of the data set and I'll paste it in here for your reference. We are getting the data set off of Kaggle.com. This is a house prices data set it was made for a competition of advanced regression techniques, but we are going to use it for our exploratory data analysis. Now, I've also included for you this file. It's a CSV file. You can just find it at the end of this section, so in the source files. But this is just a link for your reference of where the data set is actually from. All right, so I saved this under the name of housing_data.csv. All right, and we're going to use the Pandas library to read the CSV file and turn it into what's known as a Pandas data frame. So make sure you import the Pandas library here in your in your file here, your collab. So this library is very commonly used because it has the data frame type, which creates a data set that is of a type data frame from any data like CSV files, text files, or JSON data, and more. The result of this is going to be a data frame, so I can call this my data frame. Then I can print out my data frame to see what I have. But note that currently we don't actually have this CSV file loaded into Google Colab, so you'll get this file not found error. So what we want to do is, before we actually read the CSV file, we have to load it into this project. So I'm going to import from google.colab the files module, then I'll call files.upload. This allows me to upload a file to this Google Colab instance. And if I run this code cell, I'll be prompted to choose a file from my computer. So go ahead and select that CSV file, housingdata.csv, and hit enter. And you're going to then save that file to your Colab, and you can then reference it by its name. So now if I run that second code cell, look at that. Now I can actually see a data frame version of my CSV file. Right, and here we can see all of the different columns, but some are hidden. So if you want to see the other columns, you can either visit this link to the data set, or you can also just open the CSV file in Google Sheets or in Excel or any program that works with CSV files. You can open it and check it out. You can also open it in a text editor, but just make sure you don't accidentally make any changes, or that the editor doesn't make any changes on its own, because sometimes that can happen. That's why I do recommend opening CSV files in some kind of program that's specific for CSV files. All right, so here we can see we have several columns, and we're going to look at all of the columns in this course. We can get some of the important or even introductory parameters from this data frame already. For example, I can get the shape by grabbing that shape property. This will return for me the number of rows by the number of columns. I can also get info from my data frame with dataframe.info, but that is a function, so make sure you have these two parentheses. This will tell us all of the different columns we have. So look at this. We see that we have a Pandas data frame, we have a range index, and the data columns. In total, we have 81 columns, quite a few different features, and we have 1,460 entries, which means we have information about 1,460 different houses, and we have 81 features per house. Here we can see we have the index of the column, followed by the non-null count of the column, which means how many rows were not null. Then we have the data type of the column. So we have columns like ID, subclass, zoning class, lot frontage, lot area, street, alley, lot shape, condition, year built, as well as foundation, heating, kitchen, garage area, and sale price, sale condition, year sold, and many, many more. Now, some of these features are categorical, meaning they can be put into a category, like year sold. That's a category. And month sold, that's also a category, January, February, March. But other features are known as linear, so they are actually on a scale, like, for example, sale price. That is not some kind of categorical value like A or B. Sale price is a range. So take note that there are different types of features. Some are categorical, some are linear. And we're going to look at how we can work with those features. So it's categorical and numerical is what they're typically called. And we're going to learn how we can work with both of those different types of features. You can get a hint as to which are numerical and which are categorical, because typically a numerical feature is going to have some kind of number, like an int or even a float, as its type, whereas A categorical feature is going to have an object as its type, typically. Also, a category can be an integer because that can be a label, like 0 for January, or 1 for February, 2 for March, etc., like months sold, where you have a number per month. So it's an int 64, yes, but it's still categorical. All right, and that is how we can load our data set into our project and convert it to a data frame. All right, coming up next, what we're going to do now that we have built in our data set, put it in here, we're going to learn how we can start to analyze the features of our data frame, starting with the main feature. Now, what is the main feature? Well, the main feature is going to be our sale price because that is typically the target feature. We would use all the other features to find out sale price. That's a very common problem or a very common question, is which features affect sale price. Now, we don't want to work with all 81 columns. That's quite a lot. So I'm actually going to just get some of the most interesting columns instead. So let's take our data frame and let's reassign it to equal only some of the columns that we want. So we can use, for example, numerical features. We can define a variable numerical features, and also we can find a variable categorical features. And this means we can select only the columns that we want to work with. So let's start with numerical features. Sale price we definitely want because that is typically the target feature in a lot of questions, as well as a lot area. Let's also do overall quality and overall condition and year built. And let's also do first floor SF square footage, as well as second floor square footage. And let's do bedroom above ground, so the number of bedrooms above ground. These are all numerical features because they're typically on a range. And we can include more as well, but these are the most interesting ones. Next, let's define, we already have it, defined categorical features. Let's assign it a value. We can have MS zoning, so the zoning area, as well as lot shape. These are all features that are in my data frame. This is corresponding to one of the columns or one of the features in my data frame. I'm just choosing the most interesting ones like neighborhood, as well as central air. Just make sure that you have the exact same capitalization and spelling for that exact column name. So I'm also going to choose sale condition, month sold, and year sold. Now you can actually choose more or fewer columns if you'd like, but these are just the ones that are most interesting. Then we can take our data frame and we can actually just change its assignment to be the numerical features plus the categorical features. So that means we're going to take our existing data frame and we're only going to get the rows, well, we're going to get all of the rows, but only the columns of the numerical features and the categorical features that we want. All the other columns will be ignored. So I can then print out my data frame and I will see just that. So if I run this code cell, okay, we now have only 15 columns, and I can also print out dataframe.info and I'll see that as well. We will have now, look at that, only 15 columns to work with. That's just going to make our project a bit easier than working with 81 columns, which is quite a lot. All right, next step, we're going to start analyzing our data even further. We're going to learn how we can analyze that main feature, which is going to be sale price. So join me in the next lecture where we will continue our project. Hello everyone and welcome back to our course. In this lecture, we're going to start analyzing one of the features of our data set. We'll begin with sale price, which will be our main feature. It's also commonly the target feature. So commonly you'll see machine learning projects or even data science projects that use all the other features or several other features to try to predict sale price. All right, so let's create a new code cell. And first, we are going to get a descriptive statistics summary. So we can get our data frame at the column we want, which is sale price. Then we can use the describe function. And if we run this code cell, we'll get some statistics, including the count, the mean or average, the standard, the minimum, 25%, 50%, 75%, and maximum. As well, we get the name of the column and the data type. Next, let's create our first graph with this column. So we're going to create a histogram, which is going to be showing us the distribution of values. So let's take the data frame at the sale price, and we're going to see how frequently values appear. So I'm going to use the hist function, which is available to us because data frame is a Pandas data frame. And then I'm going to pass in here the number of bins that I want. I'm going to choose 20. Then if I run this cell, look at that. I now can see the distribution of all of my values, and I can also separate them with an edge color. So let's set an edge color of black. All right, then we'll rerun this code cell. And look at this. This shows us the frequency of sale prices. So here we can see the sale price is on the x-axis, and we also have our frequency, which is on the y-axis. So it looks like the most frequent sale price was, let's see, we have here about 125,000 to 150,000. That is the most frequent sale price. And the least frequent sale price was 750,000 because it did have one instance, not zero, but it was the least frequent, along with some of these other ones as well. So just like this, we get a quick visual of the distribution of our data. Now that we know how to work with one of the features, we're going to look at how we can look at multiple features at a time. All right, so join me in the next lecture. We're going to go into not just one feature, but we're going to look at all of the numerical features, so those that can be on a range. Join me in the next lecture where we will continue our project. Hello everyone, and welcome back to our course. In this lecture, we're going to analyze more of our features of our data set. We're going to look at the numerical features first. So let's create a new code cell here. And I am going to grab our data frame, and at the numerical features, I'm going to call the describe function, then run this code cell. And this is going to give me a summary, a statistical summary of each of the columns that correspond to the values in my numerical features list. So we have our sale price, and we can see all of the statistical descriptions for the sale price, lot area, overall quality, overall condition, year built, first floor square footage, second floor square footage, and bedrooms above ground. All right, and just like that, we've gotten a quick description of our numerical features. Next up, let's make this a bit more visual. Let's create histograms for all of these features. So I'm going to take my data frame, and at my numerical features, I'm going to call the hist function to make a histogram. All right, and let's see. I am going to set my edge color again to equal black. I'll set my bins to equal 20 again. And then I can just run this and we will see our histograms. Okay, look at this. We get a histogram for every single column. Now, it's kind of overlapping, so what we want to do is set the figure size. The fig size we'll set to 14 by 5. We can also set the layout, which is going to show us how many we want per instance, so per column. There we go. So that looks a lot bigger now because we set the figure size to be larger and the layout to be 2 rows by 4 columns. So look at this. We now see a histogram for sale price, and we can see that the most frequent sale price, okay, we already had this actually, we saw this earlier, but now we have lot area as well. So we can see that for lot area, there's really only 3 different lot area categories for our binning. And the most popular one was about, well, it's a bit hard to read, so I would make these even bigger. Honestly, let's see, let's do 2 by 2 to make it a bit easier to read here. Then I'll hit run on this code cell again. Okay, let's see. Yes, if you do 2 by 2, you just have to make sure that you can still fit the number of columns you have. So we have 8 columns, so we actually have to do 4 by 2. So that will give me 4 rows with 2 of our different columns per row. And also I'm going to increase the figure size. Let's increase this to 14 by 14. So we'll get a square figure, and that will make it a lot easier to read. Okay, great. So now we can see our figure size is 14 by 14, a square, and the layout is 4 rows and 2 columns. So now we can read a bit easier these distributions. So we can see that the most popular lot area distribution now was from 0 to 12,000. Then we go on to overall quality. You can see again the most frequent appearances of ranges of quality. Same with condition. And year built, we can see that the majority of the houses were built after the year 2000. We can see the majority of houses have approximately 750 to 1,000 square footage. And note that it's not really majority actually, but I should say it's the frequency. The most frequent occurrence had that many. It's still not the majority because majority would have to be 50%. All right, and for second floor square footage, we can see the most frequent occurrence was actually quite an outlier from all the rest. The most frequent one for square footage was about 0 to 100 square footage. And that makes sense. Most apartments are that big. Then we have bedrooms above ground. The most frequent occurrence was 3. So not necessarily the majority, but it was the most frequent number that occurred in the data frame. All right, next up we can continue, and let's say we wanted to do some calculations. So what if we wanted to get the age of the building? Well, for the age of the building, we actually don't have it as a column. We have year built, yes, and we could then perform some math and we can get the current year and subtract the year built, and that would give us the age of the building. But what if we wanted to get the age of the building when it was sold? Because often that's a factor in housing. You know, the more new a house is, typically that will increase its likelihood of being sold, but not necessarily, because those are also the most expensive. So let's now calculate how many houses were new when they were sold. So for that, I'm going to have to create a new code cell, and I'm going to have to create in my data frame a new column called age when sold. And I'm going to take my data frame and I'm going to take the year sold column and I'm going to subtract the data frame at the column of year built. So just make sure you have the exact same names because it is a little bit different, year sold versus year built. And you can verify that we do indeed have those columns in our initial CSV file. So that will give me the age of the house when it was sold. All right, and then I can, after that, take my data frame and, well, just like that, it will actually already have the column in it, but I can append it to my numerical features. I can append the age when sold to these features if I want it to be used later on. Then I can get my data frame at all of my columns again that I wanted, all of my numerical features, and I can now see I'll have this extra histogram for age when sold. I could also just show that individual histogram as well. It's another option. So if I wanted to just show the individual one, I would just, let's see, I would take the exact same thing I did for the sale price and I would just show that. But I would replace sale price with, of course, age when sold. And if I run this code cell, look at this. I have one histogram again only instead of all of them because I only chose one column. And look at this. We now see the distribution of houses, the frequency of the ages they were when they were sold. So the most frequently sold houses were the newest. And we can see that because the highest bar here is between 0 and about 7.5 years. So this has already given us some very valuable insight into our data. Coming up, we're going to look at what we can do with categorical data because this has been so far numerical data on a range. So join me in the next lecture where we will learn how to work with categorical features.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.